तो इसमें अब ये कि the last thing that we did was कि we talked about एक सेकंड में वहां तक पहुंचू. As the last thing we're going to start comparing acids, specifically carboxylic acids. So now there's going to be a within acid comparison. So the last time what we did was कि I told you कि uh, what I told you was कि carboxylic acid ionizes and वो जो यहाँ पे the negative charge, it actually gets pulled by the other oxygen, so the electron negative charge gets distributed, which is why what happens is कि the negative charge density becomes very very less. ठीक है, so the negative charge density becomes really small. You've got a very small or low negative charge density over here. So if the negative charge density becomes less, there's less attraction for H+1 ions, which is why it's not going to it's going to ionize very easily. The H+1 will leave very easily. The OH bond is going to be it's going to be very very weak. तो ये था. अब अगला जो part है ना वो ये कि within carboxylic acid. So the first thing is within carboxylic acid they talk about the length of the carbon chain and its effect on the carboxylic acid. So length. So alkyl chain length and its effect on carboxylic acid strength. ठीक है, so the simple idea is that the longer the carbon chain, the weaker is going to be the acid. ठीक है, so if I have a molecule which is let's say ethanoic acid will ionize. It's going to lose the H+1 ion. And similarly, I've got a carboxylic acid that's got a much bigger alkyl chain. So I've got one second. अच्छा, so I've got another carboxylic acid. उसकी जो length है ना, that's bigger in size. So that is also going to ionize. हाँ जी, बस अभी start.
सरोज आपने कहाँ से स्टार्ट किया? अच्छा,
बस यहीं से start हुआ है. ठीक है, कि length of carbon chain and its effect on carboxylic acid. ठीक है. So the idea is that if you have a longer alkyl chain, there's going to be more. A smaller alkyl chains have electron donating effect. So if you have a bigger alkyl chain, there's more electrons, so there's going to be more electrons being pushed. So there's going to be electron donating effect over here as well. दोनों के अंदर होगा, बस उसमें it's going to be smaller. So bigger alkyl chains, you have larger electron donating effect. It's a larger electron donating effect. In bigger alkyl chains. So because of that, what happens is if you have a larger electron donating effect, the negative charge over here is going to be larger as well. And that will lead to more attraction. So that's going to lead to more attraction. So it's going to be harder for it to. हाँ जी.
सर तो ये फैक्टर्स लाइक डायरेक्टली प्रोपोर्शनल एक दूसरे के?
हाँ, तो बस वो है कि if you have a large electron donating effect in bigger alkyl chains, ठीक है, that leads to, मतलब उसकी मैं reasoning लिख देता हूँ. So when you have a large electron donating effect in bigger alkyl chains, एक second. बस हाँ, ये स्टार्ट होने वाली है. ठीक है, I'll probably message you. ठीक है. अच्छा ये बस रीजनिंग, लेट मी राइट द रीजनिंग कि large electronegative effect in bigger alkyl chains that leads to a higher negative charge density in the ion. In RCO minus one, which making it unstable. And when it becomes unstable, so what happens is कि C so it's going to be a weaker acid. So that will lead to more attraction for H+1 ions. That will lead to a stronger OH bond. So it's going to be less likely to ionize, less ionization. Hence, it's going to be a weaker acid. So hence, this is going to be a weaker acid. So main takeaway is कि bigger alkyl chain, you got a weaker acid. ठीक है, bigger alkyl chain, and you eventually end up with a weaker acid. ठीक है, तो ये clear है सारों को? तो yes or no, is this part clear?
Yes, sir.
Sir.
हाँ जी.
सर तो इससे लाइक कम आयनाइजेशन होती है तो कार्बोक्सिलिक एसिड स्ट्रेंथ तो मतलब फिर कम होगी.
कम होगी ना, वीक है ना.
ओके ओके.
बड़ी चेन होगी तो negative charge will be larger, and that's why the H+1 will be more strongly attracted to, so it's going to less ionize. ठीक है, so it's going to be a weaker acid. अच्छा, फिर इसी में ना there's another thing which is chlorine substituted carboxylic acid. Okay, what happens in chlorine substituted carboxylic acid? As a Cl substituted carboxylic acid. Now what happens in this case is कि, now remember chlorine has an electron withdrawing effect. So first thing, let's say कि there's a carboxylic acid, ethanoic acid, और उसके साथ में there is a methyl group attached to it, and it's -1. ठीक है, the electrons are left and the H+1 ionizes. और फिर आपके पास है, you've got exactly another one which is exactly the same except for one minor difference.
सर
हाँ,
सर आपने कहा है कि ये क्लोरीन जो ये इलेक्ट्रॉन में ड्राइंग है ना, तो ये तो उसके अंदर नहीं था, ये तो मतलब नाइट्राइल था, उसके अंदर अमोनिया था, वो आ रहे थे उसके अंदर,
किस में?
वो इलेक्ट्रॉन में ड्राइंग ग्रुप्स में.
नहीं, क्लोरीन वो तो बेंजीन के साथ था. इसका बेंजीन से, वो
ओके
बेंजीन में होता तो उसके लोन
ओके
पेयर उसके साथ मिल जाते थे ना. तो यहाँ पे तो इलेक्ट्रॉन क्लाउड ही कोई नहीं है ना, सो दैट विल नॉट हैपन. ठीक है यार, ठीक है, बेंजीन में इट वाज एक्चुअली अ डोनेटिंग ग्रुप, यहाँ पे नहीं है. ठीक है. अच्छा,
ओके.
खैर खैर, the difference is के what's going on over here is you've got a chlorine and it's got an electron. So the molecules are exactly the same except for one fact, which is that you've got a chlorine in one of the molecules, and chlorine has an electron withdrawing effect. So chlorine is going to kind of very slightly withdraw electrons. So what will happen to the negative charge density over here? It's going to become lesser. And that is why there's going to be less attraction as well. Okay, that will lead to, so that's going to lead to less attraction. So stronger acid होगा. So C इसमें बस वही लिखते हैं कि same thing. Cl has electron withdrawing effect. और ये बार बार लिखना पड़ रहा है. But I'll tell you just all the scenarios. ठीक है, electron withdrawing effect, and which is why what happens कि इसको short करके थोड़ा लिख लेते हैं. Electron withdrawing effect. So वो जो ion है ना, CO -1 ion, that charge density decreases, it becomes more stable. It decreases, becomes more stable. The OH bond becomes weaker. And there's going to be less attraction for H+1 ions. So hence, it's going to be a stronger acid. There's going to be more ionization. So you're going to have a stronger acid and it's going to ionize more. Relatively a stronger acid, okay? And it's going to lead to more. So it's going to lead to more ionization. तो ये आपका हो गया उसके साथ with Cl, ठीक है? Then you have another one which is the position of the Cl also matters. Let's say you've got, अच्छा इसी के अंदर let's have another one, ठीक है कि so the more chlorine substitution happens, the stronger will be the acid, ठीक है? So let's say they've got another one, और इस वाले में ना there are actually 3 Cls.
Sir,
Hmm.
sir, the question is, so तो like जितनी ionization easy होगी हमारे पास उतनी में like stronger acid होगा?
हाँ जी.
Okay, sir.
अच्छा तो यहाँ पे ना there's a lot more electron. I mean, you got more Cls, there's more electron withdrawing effect, ठीक है? So तो यहाँ पे the negative charge will actually be even lesser, ठीक है? And that would lead to even less attraction for H+1 ions. Even lesser negative charge compared to the previous one. ठीक है, so the acid strength, more Cls, you got a stronger acid. तो मतलब आप इसको summarize कर सकते हो, more Cls, and that is resulting in a stronger. So that is producing a much stronger acid, ठीक है? अच्छा, so anyways, that's this. There's a second another question that they ask is the position of the Cl. So I'm going to have 2 carboxylic acid and they will have exactly the same. ये पिछला वाला तो clear है ना सारों को? Alicia, Anna, is this clear? ये नसीब clear है? उमर clear है? सिद्रा?
Yes, sir.
Yes, sir.
अच्छा, अब ये अगला वाला, the position of the Cl also matters. कि what matters is कि where exactly is the Cl, ठीक है? So let's say you've got a propanoic acid molecule and there's double bond O and OH, ठीक है? The acid dissociates, ठीक है? The O has, so इस पे ना there's hydrogens, and there is one Cl, ठीक है? That Cl is, let's say, over here, ठीक है? There's one Cl, and there's exactly the same molecule, but in that molecule, you also have one Cl as an electron withdrawing effect, a group. But in this case, the Cl is actually not here, but it's actually over here. Or वहां पे ना there's instead there's an H over there. ठीक है, so you've got an H over there. So now if you look at this, because in the first one, because of the fact कि जो Cl है ना, that's a lot further away, and in the second one the Cl is like right next to it. So there's going to be, because it's closer, because the Cl is closer, the electron withdrawing effect is even more. ठीक है, so mainly because ये double arrow show कर देता हूँ कि since it's closer, there's going to be more electron withdrawing effect, and this negative charge will actually be smaller in size. And तो बस ये उसकी वजह से the ion will become more stable, and this one will be a stronger acid. तो आप वो सारी बातें लिख सकते हो कि so this one over here will be relatively the stronger acid compared to the first one. So Cl is closer, more electron withdrawing effect. Your ion becomes more stable. RCO -1 ion becomes more stable. It has a lower charge density. So there's going to be less attraction for H+1 ions. और क्या था कि the OH bond will become weaker. So the OH bond becomes weaker, and so more dissociation. बल्कि इसको ना make sure you write it as dissociation, because ionization is also correct. But usually we call it dissociation. उसका constant भी होता है, dissociation constant, which was K. So you're going to have, हाँ जी,
सो मार्क्स स्कीम के अंदर कौन सा एक्सेप्ट होता है?
दोनों हो जाते हैं भाई, दोनों इंटरचेंजेबली। वो असल में इशू ये है कि रिमेंबर दिस के मार्केट स्कीम इज जस्ट one accepted answer. ठीक है, in reality जो actual the way they check the exam, they're like 10-12 different, like every student in the world is actually writing something else. ठीक है, yeah, he's using his own words. तो वहां पे ना they're like 5 to 10 different acceptable answers. समझ आई बात? वो मार्केट स्कीम जब बनाते हैं ना, they just choose one answer that because obviously they can't write, it will be a very big marking scheme if they wrote all the accepted answers. मतलब समझ आइए बात मेरी?
यस
तो मतलब वो मार्किंग स्कीम में जो वर्ड लिखे हुए ना, वो 100%, मतलब इट्स नॉट के you if you write anything else that you won't get marks. ठीक है, there's a lot more different versions of answers that are acceptable. I mean, ये पूरी जो statement लिखी हुई है, that could be like, imagine कि if there are 200,000 people giving the exam, so I mean there would be a lot of variation in what people write. So there would be a number of different terms that are going to be accepted. अच्छा, लेकिन वो जो मार्केट स्कीम आ रही थी, sometimes it's ionization, sometimes it's dissociation. अच्छा, the next one के अच्छा, that's about it. ठीक है, that's it. तो ये सारा था. We did all of it. You should know all the starts है ना, कहाँ से शुरू हुआ था? यहाँ से you have alcohols, phenols, and you've got carboxylic acid. Alcohols are like terrible acids, almost no reactions. Phenols have reactions with strong bases. Carboxylic acids have all reactions. नसीब मुश्किल इसलिए कि वो भी आएगा ना, it's going to be, AS is going to be part of this. Well, not all of it, but most of the question will be on A2, but मेरे ख्याल से आसान है. इसके ज़्यादा थोड़े से ना, it's more, it actually depends. You've got a 100-mark paper, ठीक है? Sometimes in that 100-mark paper, out of 100 ना होता ये कि there's at least 25 marks that questions that are difficult. I mean, it's like a 75 marks paper that's easy or moderate, and there's at least 25 marks that is difficult. Sometimes that could be an organic question that could be very difficult. Sometimes it's some other question, ठीक है? तो मुझे personally आसान लगती है. It's relatively easy. AS probably had more reactions, ठीक है? जैसे इसके अंदर it's just one concept, electron withdrawing or electron donating, ठीक है? That's about it. And it's always the same answer, ठीक है? Okay, if you add Cl, it starts at withdrawing electrons and the acid becomes stronger. If you've got a carbon chain, phenol के अंदर you got a benzene and it starts withdrawing electrons, ठीक है? So in alcohols you have a alkyl chain that donates electrons. So the concept is pretty much the same. As the next one, still, we're going to talk about bases now. Acha, is strength of bases. Now, so what kind of reactions do bases undergo? Whenever you have a base, अच्छा,
सर
हाँ जी.
सर तो लाइक अभी आप जो ऑर्डर लेके चल रहे सर वो क्वेश्चंस के लाइक बेसिस पर है ना?
हाँ.
ओके सर.
क्योंकि वो सिलेबस वाइज और बुक वाइज ना वो फिनोल्स की एसिड स्ट्रेंथ कहीं और मेंशन है, कार्बोक्सिलिक एसिड की एसिड स्ट्रेंथ कहीं और मेंशन है, अल्कोहल्स किसी और चैप्टर में है, लेकिन वो क्वेश्चन तो एक ही आता है ना. सो आई जस्ट पुट इट ऑल टुगेदर, ठीक है? अच्छा, सो ये वाला दिस इज बेसिस, ठीक है? बेसिस, व्हेन वी टॉक अबाउट ऑर्गेनिक बेसिस वी बेसिकली टॉकिंग अबाउट नाइट्रोजन बेसिस. अच्छा, why is nitrogen a base? What is a base, by the way? It's something that accepts H plus ions. अच्छा, and they're not strong bases, ठीक है? They're all weak bases. So all are weak. So when we talk about strength of bases, we're basically doing a relative comparison. Strong does not mean strong. Strong भी weak ही होती है. It's just a relative comparison that is stronger compared to the other ones. अब ये कि nitrogen bases, ठीक है? So why is nitrogen a good base? Because let's pick the simple example of ammonia NH3. So why is it a base? Because it's got lone pairs. And since it's got lone pairs, it's going to be attracting H plus 1 ions. These H plus 1 ions are going to get attracted to it. And they would end up forming a dative bond, a coordinate bond. Okay, so these two molecules will attract each other. And the H plus 1 is going to come closer to it, and eventually they would form a dative bond. Okay, but there's going to be a dative bond that's going to be formed between them. The plus 1 charge will now be on the entire thing, because a neutral thing is getting added to a positive H. So the whole thing now actually has a plus 1 charge, and that's your ammonium ion. So ये होता है. That's why nitrogen is a good base, because it's got these, as it's got these lone pairs. So whenever you see nitrogen, that's you got lone pairs. So starting with you have 4 molecules कर लेते हैं, ठीक है? You've got 4 molecules, and the first one is an amide. ठीक है? Amide is CH3 C double bond O in H2. उस N के ऊपर ना you got lone pairs, and so this is, अच्छा, amide में it's C double bond O with NH, so there might be another carbon chain on the other side as well, ठीक है? So this is what hopefully everyone knows what an amide is. Amides are, I mean, proteins are an example of amides, polyamides. वरना polymers होते हैं, ठीक है? So amide is this thing, the middle part. C double bond O with NH. ठीक है? That's what an amide is. अच्छा, फिर second one, you've got phenylamine. That's for that you need a benzene with an amine. So you've got this thing, and it's got NH2, and that N has lone pairs. ठीक है? That's a phenylamine. अच्छा, अब फिर कौन सा है? There's ammonia. We can put ammonia in the middle. That's like our reference. And finally, you've got alkylamines. That's an amine that's got a carbon chain attached to it. And it could be, these ones also are primary, secondary, and tertiary. They could be so in सारों के पास lone pairs, and so there could be two carbon chains attached to an amine in the last one. ठीक है? I'm talking about the last one. So this is your ethylamine. हाँ, amines की ना 3 types होंगे. मतलब primary, secondary, tertiary amine, it's not in your syllabus, by the way. But it's the same concept. I mean, you will get, they won't ask you whether it's a primary amine or a secondary amine. But amine का idea होना चाहिए, it's got a carbon chain that's attached to it. अच्छा, अब the first one, ठीक है? So the first one is not basic. The very first one. This one is not basic. And this one, remember, which is it's a relative comparison. The last one, that's so this one is strongly basic. That's your last one. That's strongly basic. Or when you move to the right, the strength of bases or basicity, it increases. ठीक है? So they're ordered in this way. तो यहाँ पे strength of bases जो है, that's increasing to the right. ठीक है? So the first one is not basic. The next are actually more and more or increasingly basic. But all of them, remember, are actually weak bases. ये बस relative comparison है. मतलब the other things are a type of ammonia, you can say that. मतलब
सर
हाँ,
सर पिछले वाले की तरह इसमें हाइड्रोलिसिस या मतलब कोई और रिएक्शन होगा?
नहीं, हाइड्रोलिसिस क्या? पिछले वाले में तो हाइड्रोलिसिस नहीं था. पिछले वाले में तो
सर
वही.
वो एसिड वाला.
हाँ, तो वो H+1 लूज कर सकता था ना. अब यहाँ पे उल्टा है. You have to accept an H+1, right? तो if you want to accept an H+1, तो who's accepting? अच्छा, तो idea basics है कि you're accepting an H+1. So who's accepting the H+1? Who's attracting the H+1? The lone pairs. ठीक है? So the lone pairs के ऊपर अगर negative charge, if it's got a higher charge density, there's going to be a stronger attraction for H+1. It's going to accept it more strongly. Vice versa, if the lone pair is like has a lower charge density, तो then it's not accepting H+1. ठीक है? तो बस ये आइडिया. जैसा पिछले वाले में ना, इसके अंदर नेगेटिव चार्ज ज्यादा होगा तो यू गोना बी अ स्ट्रॉन्गर बेस. पिछले वाले में द नेगेटिव चार्ज हैड टू बी लेस because you didn't want to actually, you wanted to let go of the H+1. ठीक है? So the negative charge had to be less. यहाँ पे the negative charge has to be bigger in size. अच्छा, सारों की रीजन लिख लेते हैं, स्टार्टिंग विद द फर्स्ट वन, ठीक है, वेरी क्विकली के, तो स्टार्टिंग विद द वेरी फर्स्ट वन, दिस वन. So this one is not basic. So what's the reason? What's the reason for that? अच्छा, अब इसमें होता है कि your lone pair is right next to a very highly electronegative oxygen. So what actually happens is the lone pair actually goes missing. It ends up overlapping almost completely with the pi electron cloud in the double bond over here. So वो lone pair होता ही नहीं. So who's going to accept the H plus one? No one is going to accept the H plus one. So it's not basic. And the reasoning will be that the lone pair overlaps with a lone pair on N in amide. ठीक है, it overlaps with pi electron cloud in C double bond O. Why? Because as oxygen has a strong electron withdrawing effect. So oxygen has a very strong electron withdrawing effect. So since it's got a very strong electron withdrawing effect, so charge density decreases. On lone pair, बल्कि simple वो lone pair is therefore not available to accept H plus one ions. It doesn't, it doesn't decrease, it's just not there, ठीक है. So lone pair on N not available to accept. So it's not able to accept H plus one ions. So that's the answer for this one, ठीक है. If anyone is going to ask you why it's not basic, तो वो उसका आंसर है. ये भी क्लियर है?
यस सर.
और फिर ये
सर
वाला
इसके रीजनिंग के क्वेश्चंस आएंगे.
हम्म
इसके भी मतलब रीजनिंग के क्वेश्चंस याद है ना, जो बेसिस के.
हाँ, क्वेश्चन कैलकुलेशन तो नहीं आएंगे ना, वो तो ये तो है ही सारा स्ट्रक्चर्ड ना.
सर कितने मार्क्स तक की होती है रीजनिंग?
3-4 मार्क की होती है. फिर वो पूछ भी सकते हैं ना कि भाई वो मे बी HCl डाला है, दे माइट गिव यू अ रिएक्शन, ठीक है. तो वो आपको देखना होगा कि will it react with H plus one or will it not react with H plus one. एक एक्चुअली इसी तरह का ना, there was a very complicated question के वो करेंगे बाद में. ये वाला, अच्छा, this is weakly basic, ठीक है. I mean it's not strongly basic, it's relatively. अच्छा, this one is relatively weakly basic. So why is this weakly basic? क्योंकि over here there is electron withdrawing effect. The lone pair is going to mix up with the benzene electron cloud, but the electron withdrawing effect is not that strong. So the negative charge density on the lone pair decreases. यहाँ पे थोड़ी सी कम हो जाती है, but it's still there. So it is still capable of accepting or attracting H plus one ions. So it's weakly basic. Lone pairs on N, पिछले वाले केस में तो completely withdraw ही कर गया था ना, it wasn't even there. So lone pair on N slightly, you have simply overlaps with benzene's pi electron cloud. With with benzene's pi electron cloud and its charge density decreases. So because of that, there's less attraction for H plus one ions. You have weaker attraction for H plus one ions. And it's weakly basic. So what's going to happen if I have this reaction? I mean, this thing, if I इसकी equation भी लिख लेते हैं, if this thing reacts with let's say वो HCl के साथ react करता है, ये सारा मैं हटा देता हूँ. अच्छा, so what if this thing reacts with HCl? So what will happen is कि जो top वाला part है ना, this one, there's going to be an H that will come and join with this, and the whole thing will actually have the whole side will have a positive charge, but you're going to call it NH3 plus 1, okay? And there's going to be Cl minus 1 that will be left in the solution, okay? So the H plus 1 is going to get accepted. तो ये और फिर एक there's this last one. So that is relatively the strongest of all the bases because it's got an electron donating effect. So in Saramena, this is the one that happens to be, इसको भी कर लेते हैं, this is the one that happens to be strongly basic. Relatively strongly basic. They're all weak bases. So this one happens to be the one that's strongly basic. Why is that? Because you've got an alkyl chain, and that alkyl chain has an electron donating effect. So lone pair के ऊपर charge density increases, so there's going to be more attraction. So that's it. Alkyl chain has electron donating effect. And what happens because of that is that charge density on lone pair increases and more attraction for H plus 1. Okay, your charge density on lone pair on N increases. And that leads to more attraction. And that leads to more attraction for H plus ions, and because of that, it's going to be a stronger base. So hence, it's a stronger base. बस ये खत्म हो गया. That's it. ठीक है. That's for bases. That's it for bases. ठीक है. You just need to know which ones are strong and which ones are weak. वो अमोनिया वैसे बीच में, that's just as a reference. ठीक है. ये clear है? बात समझ आई?
जो इथाइल अमाइन का लास्ट पार्ट था सर, वो एक्सप्लेन कर दे सर, तो वो क्लियर नहीं है.
नहीं, वही alkyl amines में क्या होता है? There's an electron donating effect, right? तो यहाँ पे लोन पेयर के ऊपर नेगेटिव चार्ज क्या हो जाएगा? ज्यादा हो जाएगा ना. And if it's higher, तो it's going to attract more H plus ions. ठीक है. Clear है?
Yes sir, be clear. सर वो अमोनिया का रह गया.
अमोनिया बीच वाला है ना, उसको छोड़ दो. अमोनिया एज अ रेफरेंस है ना भाई, वो उसमें डोनेटिंग इफेक्ट है ना उसमें विड्रॉइंग इफेक्ट है, ठीक है, रिलेटिवली स्पीकिंग। इसमें फर्स्ट वाले में देयर वाज अ स्ट्रॉन्ग इलेक्ट्रॉन विड्रॉइंग इफेक्ट, इसमें देयर वाज स्लाइट इलेक्ट्रॉन विड्रॉइंग इफेक्ट, इधर इलेक्ट्रॉन डोनेटिंग इफेक्ट है। अमोनिया इज लाइक अ रेफरेंस, दैट्स राइट इन द मिडिल, ठीक है, क्लियर है। तो बस कल करते हैं, ठीक है, ये हमारा खत्म हो गया वाला पार्ट। पीछे विल डू रिडॉक्स रिएक्शंस और तो नेक्स्ट हम रिडॉक्स करते हैं बल्कि।
सर
हाँ जी,
सर आप सिलेबस सर ओपन कर सकते हैं कि लाइक ओवरव्यू का पता चले कौन से कंप्लीट है कौन से रहते हैं सर।
नहीं तुम्हें सारा ओवरव्यू करना है, वो कल कर लेते हैं, मैं अभी एक और क्लास है। इसमें तुमने ऑर्गेनिक का पूछना है।
हाँ सर वो ऑर्गेनिक का मतलब वो सर लाइक कोई कितना लाइक रहता है वो पूछना था सर।
अच्छा रिडॉक्स पहले हम इकट्ठा कर लेते हैं सारा ASA2 मिला के, ठीक है, उसके बाद फिर उसके बाद एंड में मुझे खोलना पड़ेगा सिलेबस, क्योंकि वो बीच में जो छोटे छोटे रिएक्शंस रह गए ना वो फिर सिलेबस खोल के कर लेंगे। तो
तो सर लाइक ये कब तक खत्म हो जाएगा ऑर्गेनिक।
मेरा एक वीक और लगेगा, ये वाला पार्ट तो खत्म हो गया, कल हम करते हैं रिडॉक्स खत्म कर लेते
ओके
हैं।
सर।
चलो ओके, अल्लाह हाफिज।